Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss one of the topic from chemical bonding, that is FAJAN'S rule. FAJAN'S rule. According to FAJAN'S rule, no bond is 100% ionic in nature. It has some percentage of covalent nature, which is explained on the basis of FAJAN'S rule. No bond is 100% ionic in nature. It has some percentage of covalent nature, which is explained on the basis of FAJAN'S rule. According to FAJAN'S rule, covalent nature covalent nature is directly proportional to size of anion. That means anion size and inversely proportional to size of cation size. You should remember one thing, that is CA chartered account. CA means covalent nature is directly proportional to anion size. Now coming to ionic nature. According to Paul's rule, ionic nature is directly proportional to size of cation size, and inversely proportional to size of anion, that is anion size. You should remember one thing, that is IC, intensive care. That means ionic nature is directly proportional to cation size. Here covalent nature is directly proportional to anion size. Ionic nature is directly proportional to cation size. Now we see some examples. NaF, NaCl, NaBr, NaI, sodium iodide. In these compounds we have to find out which one has more covalent nature, which one has less covalent nature. So covalent nature is directly proportional to size of anion size. Here what is anion, what is cation? So Na plus F minus, Na plus Cl minus, Na plus Br minus, Na plus I minus. So negatively charged species are called anions and positively charged species are called cations. Cations always exist first, followed by anions. Now covalent nature is directly proportional to size of anion. Now we see the size of anions: fluorine, chlorine, bromine, iodine. These belongs to 7th A group elements, and the size already you know that when we are moving from top to bottom, the size of the elements increases. Now the size of the anions increases. Now which one has more anionic size? Iodide is more anion size. That's why it has more covalent nature. And fluoride, F minus, has less anion size. That's why if the size of anion decreases, covalent nature also decreases. It is less covalent nature. Now write the order: NaI, NaBr, NaCl, NaF. NaI is the more covalent nature, followed by NaBr, NaCl, NaF. NaF is the least covalent nature. This is the order of covalent nature. Now find out the ionic nature. Which one has more ionic nature? Which one has less ionic nature? Ionic nature is directly proportional to cation size. IC. Ionic nature directly proportional to size of cation. Now all cations have same size. All cations are same, identical. Now coming to anion. Ionic nature is inversely proportional to anion size. If the anion size is less, ionic nature is more. Ionic nature is more. In these anions, which anion is less size? Already you know that this is less size. So anion size is less, ionic nature is more. This is more ionic. And if the anion size is more, ionic nature is less. So this is anion size is more, this is less ionic. Now write the order. More ionic, NAF is more ionic. NAF is more ionic, followed by NaCl, NaBr, NaI. So this is the covalent nature order, ionic nature order. So ionic nature, it is completely reversed to covalent nature. Covalent nature order Na, NaBr, NaCl, NaF. Ionic nature order is NaF, NaCl, NaBr, NaCl. When it is reversed, we get ionic nature order. Next, so in this way you can explain Fajans rule. Covalent nature is directly proportional to anion size, Ca. Covalent nature, anion size. Ionic nature is directly proportional to cation size, that is Ic. If the ionic nature directly proportional to cation size. Now we see another example. Here next, according to Fajans rule, covalent nature increases by increasing charge either on a cation or anion. Covalent nature increases by increasing charge either on cation or anion. For example, SnCl4, SnCl2 and SnCl2. And what is the charge on tin? Already you know that +4. What is the charge on tin? Here +2. Here charge is more on tin and charge is less on this SnCl2. Now which one has more covalent? This is more covalent, and this is less covalent. So less covalent means more ionic nature, more covalent means less ionic nature. So covalent nature, from this we can say that covalent nature is directly proportional to charge on cation or anion. If the charge increases on cation, or anion, the covalent nature increases. Next example, pseudo inert gas configuration. If the in a compound, if the cation has pseudo inert gas configuration, so that molecule has more covalent nature. In a compound, if the cation has inert gas configuration, that compound has more ionic in nature. When you see example, CuCl and NaCl, which one has more covalent nature, which one has more ionic nature? We see in CuCl, the cation is Cu plus and anion is Cl minus. So which one has a pseudo inert gas configuration? Cu plus has pseudo inert gas configuration. Pseudo inert gas configuration means if the valency cell contains 18 electrons, that is called pseudo inert gas configuration. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d10, 4s0, 3d10. This is the electronic configuration of Cu positive. Now valence electrons, how many valence electrons? 6 plus 2, 8, 8 plus 10, 18 valence electrons. It has a pseudo inert gas configuration. And Na plus and Cl minus. Na plus means 10 electrons, that means 1s2, 2s2, 2p6. It has 10 valency electrons. This is inert gas configuration because it contains 8 valence electrons. In valence cell it contains 8 valence electrons. It has pseudo inert gas configuration, it has inert gas configuration. So the cation which has pseudo inert gas configuration, that one has more covalent nature. And the cation which has inert gas configuration, that is more ionic nature. More ionic nature means it has a less covalent nature. It is more covalent nature means less ionic nature. So in this way we can explain Pajan's rule. I hope that you understood my concept. Thanks to all for watching my video.